Welcome to The Explainer. You ever wonder what's actually going on inside your body when you suddenly have to sprint for a bus? It's way more than just your legs moving. It's a full-on biological chain reaction. Today, we're breaking down the incredible split-second changes your body makes the moment you start exercising. Just imagine this, the first 30 seconds of an all-out sprint. Your muscles are absolutely screaming for fuel. This is basically a biological emergency, and your body has to launch this stunning, perfectly coordinated response to deal with it. Okay, so here's our game plan for today. We're going to start with that first desperate call for energy. Then we'll see how your heart and lungs team up as this kind of high-speed delivery service. After that, we'll get right down to the factory floor, the muscles themselves, and we'll wrap it all up by showing you how knowing all this stuff can help you absolutely ace those exam questions. So, it all kicks off with one thing. The second you decide to move, your muscles send out this urgent SOS for a massive flood of oxygen and energy. Seriously, every single change we're about to talk about is just the body's amazing organized answer to that one critical demand. So, how does the body actually get all those resources where they need to go and fast? Well, that's where your cardiovascular system comes in. Think of it like an emergency delivery network that just instantly kicks into overdrive. And the response is immediate. Your heart rate, how fast it's beating, it just skyrockets. But it's not just beating faster. Each beat gets more powerful, pumping out way more blood. It's this 1-2 punch that means the total amount of blood flying around your body per minute goes up like a lot. And that brings us to a really key term here, stroke volume. That's just the amount of blood that gets pushed out with every single heartbeat. This is so important because it's not just about a faster pulse. It shows the heart is actually becoming a more powerful, more efficient pump with every squeeze. And you can see how this all works with a pretty simple bit of math. Your total cardiac output, which is the grand total of blood flow per minute, is just your stroke volume multiplied by your heart rate. And since both of those shoot up during exercise, your cardiac output just goes through the roof. And this graph shows that journey perfectly. You can see your heart rate starting at rest, then climbing super fast as you start exercising, before it kind of levels off at your maximum intensity. Then, during the cooldown and recovery, it gradually makes its way back down to normal. But here's the thing, it's not just about pumping more blood, it's about being smart with where it goes. The body has to send all that extra blood to the places that really need it. And that super smart redirection process, that's called vascular shunting. It works like a super sophisticated traffic control system. The body widens the blood vessels. That's vasodilation, opening up the highways to your working muscles to give them all the oxygen they want. At the exact same time, it narrows the vessels. That's vasoconstriction, to areas that can wait, like your stomach. Sorry, digestion, you're not a priority right now. All right, so the delivery routes are clear and optimized. But what about the cargo itself? The oxygen. How do we get more of that in the first place? Well, that's where we get the respiratory rush. Instantly, you start breathing faster, but you're also breathing deeper. And the depth of each breath, that has a name. It's called your tidal volume. So by breathing faster and deeper, you're basically flooding your lungs with air, which lets you grab as much oxygen as possible while getting rid of all that waste carbon dioxide. And these two systems, the cardiovascular and the respiratory, they are not working alone. They're in constant, perfect sync. The lungs are like the loading dock, bringing in all the oxygen, and the heart and blood vessels are the fleet of delivery trucks, rushing it out to the muscles. It's a beautiful partnership, really, and it's built for performance. Okay, we've seen how the oxygen gets delivered. Now let's go to the place where it's all happening, the site of all the action, the muscles themselves. Let's see what's going on down there on the factory floor. So as your muscles start working overtime, a few things happen pretty much right away. They generate a ton of heat, which is why your body temperature goes up. They also start to get tired, and during really intense work, they start producing a waste product called lactic acid. That buildup of lactate is exactly what causes that burning feeling you get when you're really pushing yourself. It's a direct signal that your muscles are working so hard, your delivery system just can't get oxygen to them fast enough. So they have to switch to plan B, anaerobic energy production, which is a fancy way of saying making energy without oxygen. Now that whole process creates something called an oxygen debt. Think of it like this. You've borrowed energy that you'll have to pay back later with oxygen. And that's why you keep breathing really heavily even after you've stopped exercising. Your body is working hard to repay that debt, taking in extra oxygen to break down all that lactic acid and get things back to normal.
Okay, so we've covered the heart, the lungs, and the muscles, all of which are going absolutely crazy in the short term. But what about the scaffolding that's holding this whole operation together, the skeleton?
And here's a big one, a really common point of confusion. During a single workout, in the short term, there are basically no immediate effects on your skeleton. Your bones don't change on the spot. Their adaptation, getting stronger, getting denser, that's a long-term game. It happens over months and years of consistent training.
All right, we've covered a ton of science. Now, let's put it all to the test and see how this knowledge actually helps you get the grades. We're going to break down a typical Edexcel GCSE PE exam question and figure out exactly how to apply these concepts. So, here it is, a classic 9 marker. It's really asking you to do two things. First, explain that whole vascular shunting process we talked about, and second, think about how that specifically helps out a hockey player. To nail this and get all 9 marks, you've got to hit 3 targets. First, you show you know your stuff by defining the key terms. Easy. Second, you explain the whole process, where the blood goes and where it's diverted from. And third, you have to evaluate. You have to connect it directly to the demands of hockey, like needing more oxygen for running, dribbling, and shooting. And honestly, this process is what separates the good players from the great ones, especially late in a match. When everyone's getting tired, vascular shunting is what makes sure a player's leg muscles are still getting a priority supply of oxygen. That's what lets them make that game-changing sprint back to defend and attack. It's absolutely crucial for staying in the game. So, the next time you're exercising and you feel your heart pounding and your lungs burning, just remember, that's not weakness. That's the sign of an incredible, high-performance machine pulling off a perfect emergency response. And understanding that response isn't just about passing an exam. It's the key to unlocking your own athletic potential.